Let's jump into just some basics about PMMA milling, Austin. First question is just what are the speeds and feeds of your roughing tool and your finishing tool that you set up and use for milled PMMA prosthetics?
Sounds good. Yeah, let me share my screen here because uh, many of us have heard speeds and feeds, and what does that really mean, and how does it translate to you as a manufacturer? So speeds and feeds means how fast the milling burr is one spinning, how fast in RPM, and another is how fast in a particular direction is it moving. So speeds and feeds and they're different for every machine, for every tool, for every material. And I think that's a lot of times where the conversation sort of stops. But what I wanted to show and what I have on screen here are two critical components of our milling operation here. One of them is roughing. So these tools are 4 millimeters in diameter and they are moving fast. We will see a simulation later that shows about how much material is being removed, but these roughing tools are really jamming through the material, and we want it to sound nice. We don't want the vibration to be there. We want the tool to last its expected life or longer, and we want it to work optimally. So we want to get the most out of these tools. So I will share specifically ours. RPM on the spindle is 28,000 RPM. XY feed rate 5,500 millimeters per minute. And then it's going to step down in Z. So as this burr does its tool path, and then it drops down in Z with the puck as it's milling the object out, our roughing burr moves down 1.5 millimeters each time it steps down. So to put that into perspective, when this is done milling, it doesn't necessarily look like a set of teeth, but it's removed a good 80% of the material that is surrounding the teeth. So we want to attack it really fast and really hard with the roughing tool. And then we want to come in and finish it afterwards. Um, Rob, is there anything I should mention there on the roughing tool in
Yeah.
specific before I move to finishing?
How many minutes is this roughing operation? We had talked about that.
About 5 minutes. It is freaking awesome. It
That's
is really,
fast.
it's really, really awesome. It's great to see, that aspect used to be with a 2 millimeter burr, hours, truthfully. And then now we've taken it into the minute zone, and I'm really excited about it. But to get the most out of your tools, I mentioned before the sound. You want to sit there and listen to this burr in action. And then you want to make minor adjustments. And again, listen, see what changes that you might hear. It could be a vibration sound, it could be a squeaking noise. There's many of different symptoms, but if you're going to be adjusting these speeds and feeds, make sure you're attentive to that burr and don't just make a change and then run the mill overnight.
So you're like a doctor with the stethoscope on your mill,
Yeah,
making sure
everybody,
it sounds good.
you know, we're turning the other machines off. We're sitting very, very close to it, and very similar to that. Yeah. Just sort of listening to anything that may sound off, right? And early on in this, for me, there's not a lot of training on this, so you kind of make an adjustment. You hear an audible change, and if it gets better or worse, you make an adjustment based on that. And then, in addition to sound, you got tool life. So we're recording tools. How long has this tool been lasting? And then notate when a change is made, and then continue to record tool time. See if you're optimizing your tool or if potentially you're losing some of that life.
Awesome. So yeah, talk to us about finishing, and then maybe we'll go into the milling simulation and you kind of show us a little bit.
Yeah. Finishing done primarily with a 2 millimeter ball nose carbide tool. It does this much slower. So you're looking at finishing on a particular part for us. If the total milling time is 1.5 hours, about an hour of that is being used to finish. Okay, so when we're doing the bulk of it with a 2 millimeter tool, and then we'll come in and we do what's called rest machining or milling the rest of it, what's left behind with a smaller tool, a 1 millimeter, a point 0.6, or potentially even smaller. So for our finishing tool path, it's done with a 2 millimeter ball nose tool. The spindle speed is 25,000 RPM. The millimeters per minute in XY is 1800, and that Z step down is 0.12. So significantly different than our roughing, right? That means as this burr is going around, and then when it moves down, it's moving down just over a tenth of a millimeter.
Hmm. All right, let's take a look at the simulation.
All right, that sounds good. So first we're going to look at that 5 minute job, right? This is the roughing tool. It's our 4 millimeter carbide tool, and it's going to get the bulk of this PMMA out of the way. So we've got it started at the beginning. We'll talk about this, but this is simulation. This is watching your mill before it does the actual milling. So here goes.
Is single flute, double flute tool?
Single fluted 4 millimeter. Um, and yeah, carbide, no coating. We're milling PMMA, so there are some additives that can make your tools last longer, but we don't need any coating like a diamond or something to specifically cut PMMA. A raw carbide burr is sufficient.
And you always run milling simulations for all your jobs?
Yep, every time before we press start on the milling machine, we want to make sure that the result is anticipated to be perfect. It's a huge loss in time to pull a puck off of a machine, identify that there's an issue, go back to simulation, see that issue, and think, man, I wish I caught this beforehand. So it's happened enough times in my career that I have made it a hard and fast rule to always simulate before pressing go. So we've actually already moved on past that roughing job. I'm going to run it one more time so we've got just a clear picture of about how quick that is. And this is maybe, you know, 400% time as far as the speed, right? It's not really moving quite that fast, but the roughing pass, occlusal and cavity side, it takes about 5 minutes. Now
Awesome.
I'm gonna,
We
oh,
got a
go
couple
ahead. Yeah.
questions here from Brian. He asked, "What mill are you using?" And then Amir asks, "Can I use those parameters with all CNC machines?"
It's a good baseline that's been optimized. So yes, you can use those speeds and feeds for your particular machine. Like I said, listen to it. Maybe sit there while that job mills after you make this change. But yeah, these should switch over to most mid to industrial size mills. You wouldn't want to run these feeds on a Roland or anything, let's say a smaller caliber machine. But yeah, they're good baselines that have been optimized.
Does spindle speed matter then with this speed and feed rate?
Yes, every single component of speed and feed relies on each other. So the spindle speed, the amount of flutes, that is a direct correlation. So if you've got one flute at 2,800 or 28,000 RPM, and then you switch to a dual fluted tool, you're doubling that theoretical time that tool is touching the material. So the amount of flutes, the RPM of the spindle, the XY feed rate, and the Z step down are the four primary parameters. And I'll just side note here, ChatGPT is super smart about this stuff. You can tell them your mill, you can tell them your material, you can tell them the facts that you know about your tool, and just ask it, right? It's really, really smart in that
So
aspect.
tell the milling machine model and maybe give it some few details, spindle speed, and then it'll give you at least a good frame of reference, I bet, to
Yeah,
start
I
with.
think it's common for some offices to go from their standard tool set having the largest tool be a 2 millimeter ball tool. And then maybe your reseller has a 3 or 4 millimeter tool available for your machine. And you can plug in what you know about your current roughing parameters and your current roughing tool. You can tell it, hey, I want to use this as my new roughing tool, and it will give you feedback on a great way to start.
Awesome. And you free to share what mills you have?
Yes, I really like them. It's got to do with the quality of the parts inside. So it's not to do about who they come from, where they come from. It's about these machines and how long they're going to stay stable. XT Sarah, X T E C E XTCERA, XT Sarah, and they are really they're semi-industrial machines. The components used, the gears, the drives. So for milling PMMA, the single disc option is called the 500. The multi-disc option, it has 12 discs, is called the 580 DC. And our titanium machine is called the 650 SE. Those are the three machines that we run primarily. I have the 580 and the 650 here, and then we place the 500s in clinical settings.
Awesome. 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 Well, let's jump into some other juicy details about screw seat geometry, prosthetic screws, angled screw channels. I think these are pushing the limits on screw geometries and angled channels and a lot to be considered there. So just, yeah, talk us through your approach to screw seat geometry and milling, and then we'll just go from there.
That sounds good. I got to start here with this scan body. So, really, the thought about screws and what we're going to use and what we're going to manufacture, that question or thought should happen in the clinic, right? The oral surgeon, the dentist, the one taking the records should be anticipating the prosthetic screw that's going to be used. So one thing that we will talk about a few times here is my Bullard alignment healer. Dr. Jonathan Bullard and I, we do full arch surgery. We've done hundreds and hundreds of patients, and we use our scan body. The reason for that is the scan body lets us choose the screw in our CAD software. So whether it's exocad or 3Shape, your designer is using a scan body to identify an implant location and then telling that CAD software what screw to put in that place. So there's step one, right? The scan body is used in surgery. They take the records with it. The next step is the designer aligns to that scan body and chooses that prosthetic screw. And then we will talk later on about the manufacturing of it. But this same library in CAD and in CAM in the manufacturing side, it all is, we called it a sister library, right? They work together. So prosthetic screws, there's a ton on the market, right? And the thing about them is you want to be able to make the selection you want when you want to make it. So if you want to choose to use a Powerball screw, or you want to choose to use a desk screw or a vortex, you want to say, I want to make this choice, and then I want to send it to the machine, and I want it to work. So that's kind of the overarching topic today. Let's jump into our super arch. I think that'll get a couple
Yes.
questions going,
Yes,
right?
yes,
So
yes.
this is that
Walk us through.
this arch, although it's a dream of mine, right, to be successful with all of these really complicated screw geometries and settings, this case would be a nightmare for a lab. It's so many different variables. It's having them all selectable in one library. So one thing, let's kind of to connect this dots. Let's go to it's called detect implant position in exocad. So you can see we've got a tissue scan, we've got our Bullard alignment healers or our scan bodies floating in space. We use those to align to our photogrammetry scan. And then, like, this is kind of the crux of it. This is where you choose your screw. Okay. So in this menu, your designer is telling the CAD software, hey, I want to use a DES 19406 screw, or making that choice to go with a Vortex, any number of screw. But that selection is done in design. And it is best to have it be consistent from start to finish. So making the selection here that is accurate to what you're going to be manufacturing rather than, which is possible, changing it in CAM, right? Having a designer design it with one screw here and then mill it with a different screw here. It is possible, but it is best to just be consistent from start to finish. So on this particular arch, we've got 6 different screws. We've got the DES 19018 screw. We've got the Vortex screw, Seg screw, the Badger screw, Powerball, and Sin 360 has a new Smart Angle screw. So I put all of those in this arch, right? And we have a chance to look at that in the CAM. But then I also, unless you've got some questions, I was going to move over to our part.
Keep going. Keep going. I
Okay,
love
so
this.
now on screen, I've got a 6-unit case, right? We've got 6 bullard alignment healers sitting here, and I've aligned 6 different geometries, the same ones I mentioned before, and I've maxed out their angle. So again, your designer is choosing the angle or the amount of angle that's put into these prosthetic screws. Um, I want to show you here that let's go to.
Why did you create this prosthetic? What purpose is it serving for you, this test object here?
So we use this object when we get a new screw. We can pick out one, for instance, like the Vortex screw. So when we got our first case, hey, we want to use the Vortex screw on this. We take this prosthetic, we make 6 different Vortex screws. Then we put them at 6 different angles, 5, 10, 15, 20, 25, and 30. We create this object, and then we manufacture that object in various materials. So for today's topic, PMMA, right? I would mill 6 different Vortex screws with 6 different angles, and then I would go take it out of the mill. I would put an analog on it. I would take a Vortex screw and the driver, and I would try to get it to engage. We're checking a few things here. One, does the channel pass through that screw channel? Is there excess or enough room? And then does the driver engage with the head of that screw and allow full torque on that MUA? So that's some of the testing that's done with this object for us.
And you're doing all that to give yourself a positive feedback loop on achieving a certain angled screw channel with that type of screw.
That's right. And I think one of the things we identified was, um, certain screws truly allow for that extra 30 degrees or 25. Um, and some people may be able to get by with larger numbers than you see on screen here. But for us as a manufacturing facility, we want to limit things that we know we can make work to an angle that we know is repeatable on every case. So again, those things are sort of fine-tuned and can be adjusted.
So your manufacturing, limits that you validate then determine your design limits.
Yeah, we provide as Elite Dental Manufacturing, we provide this library to not only our clinicians, every designer, and me as the manufacturer. Everyone uses this same cohesive library, so everyone can give feedback if they see an issue, or if we've got something new that comes out, we can roll it out, we can implement it into this library, and then it's available to all of our clinics.
And we'll keep going, but I'll drop in your email address. So if someone wanted to reach out to you and get a copy of this
Yeah, if
STL
you're
file.
listening, If you're listening now and you want to write this down, it's Elite Dental Manufacturing. That's the name of my business. My email address is Austin at edm dot dental. So it's pretty short. Austin at edm.dental. Shoot me an email. I'd be happy to help in any way possible on all on X cases.
Awesome. I just dropped it in the chat, so everyone's got it.
Cool. Any questions? Anything on the
No, let's
message
keep
board?
going through, angled screw channels and screw seat geometry. Talk to us about, uh, there's a milling strategy coming in through the screw channel, and then you've got a milling strategy potentially coming up using a T tool. Talk us through the geometries of the screw seat and, what you're doing in your process of validating, milling those and how to achieve a good screw seat in an angled screw channel.
Sounds good. So I think the first angled screw that I saw on the market was Jonathan Abenine's Powerball, and it allowed us to mill these angled cases without needing some special tooling, right? It allowed us to come in. It's the second one from the right here, so it allowed us to kind of come in from this occlusal surface and mill all of these engaging parts of the connection from the top side. As we got more screws on the market or there was a demand for improvements on these screws, we started to need special tooling. So basically, every other connection or every other screw is going to require a special tool. And we use T-shaped tools. We have two different sizes. We have a 1.4 millimeter and a 1.6 millimeter. We'll look at them in detail a bit later, but it's basically, it looks like a lollipop, right? It's got a thin little shaft and then it's got a T-shaped tool that is wider on the top. So it threads that tool up through the bottom and it comes in and it oscillates around to specifically mill the engaging screw seat portion.
Yeah, so if
Uh,
you're doing angled screw channels, are you always using a T tool with that?
yes. Yep. Every one of them, if they don't require a T tool, they are certainly cleaned up and benefited from the use of a T tool.
So even if someone was like, "Well, you don't need a T tool with this screw," you would say, "Well, I'm gonna use one anyway just for perfection."
The CAM software is smart enough, actually. I'll tell you that. So you set up your CAM. It's going to look at these objects. It's going to know if there's an angled screw channel. It's going to think about the result it can produce. And if it can produce a better result by using the T tool, it will automatically do that in Millbox.
Wow, awesome. Well, let's maybe look at some of the simulation that you showed us with, you showed
Yeah,
us the
let's go
leftover
to a
material.
I'm
Go
going to
ahead.
jump back to our live simulation. This is our active window that we were looking at earlier. I've got a little recording of specifically the T tool, but let me jump down here to where it first uses this T tool. So it's done it's done all of the roughing. It's done most of the finishing, but it's going to come in and now it's going to address the screw parts, right? The MUA seat, the screw channel, all of those aspects. So now it's going to come in with the T tool and clean up any of the screws that have angle. So on this arch, two of them do not have angle, the pterygoids in the posterior, and four of them do. So we'll be able to see it attack these four different parts here. And what I want to show you is another thing that we've looked at or that we look at in the simulation. It's called deviation. So I'm going to run it here. And now you will see if it's a green gray camo, that is perfect result compared to the STL. If you see any shade of blue, aqua, yellow, or red, that means that it's just not quite milled that detail out. So if we look down at these screw channels, the four anterior, and we zoom in, we can see this, it's called residual material, right? Deviation from that STL. And we've got it on all of the four anterior. Going to start with one and it'll proceed to the following angled screw channels. So I'm going to make the object transparent so we can see through it, or translucent here. And then let's make our tool solid. So the tool has already threaded its way up from the bottom of that screw channel. And now it's going to extend as deep as it needs to. Then it is going to start oscillating and working its way down towards that screw seat.
And
And
we got a,
you'll
sorry, go ahead.
also see in the simulation that deviation starts to remove that aqua and that blue color, and it becomes perfectly green. So this means, again, that the result compared to the STL is perfect.
Uh, Question in from Jordan. How often do you evaluate the simulation and then decide to recalculate? And what type of issues are the ones that are exposed in the simulation?
The amount of times that I evaluate the simulation is every time. The amount of times that I go from simulation back into mailbox to then maybe make an alteration or a change, or manipulate it in some way, is a low number. Is probably 1 in 10 cases. The software has gotten to be so smart. We've done enough work. We've done enough trial and error. I throw thousands of these arches at mailbox. I mean, a year for sure. And there were some hurdles in the beginning. There wasn't things, there wasn't all this stuff kind of ready to go. But we've been in this angled screw channel full arch world for, I don't know, 5 years or so. So most of the kinks are worked out.
Awesome. Well, and you've worked out a lot of those kinks, and
Oh, yeah, thanks. Yeah, it's just, I think we've all been there. We've all got a case. It's a rush case. It may be for someone else. For me, it's actually been the patient. So like, they're waiting for their new smile. So for me, when I run into these issues, I imagined other people were having them. So I just started to reach out to these companies, Sim System specifically. I would voice my problem, and they were just so happy to try to help and make it easier. And we've just been consistently working together at that capacity. So you're welcome.
awesome, man. Talk to us about the MUA tool that you've developed and how you use that and why you created it. I think it's pretty obvious, but it's really cool. You developed your own tool to solve a simple problem really quickly.
Yeah. Yeah. So for me, we mill basically all of our cases, if it's not a denture, has a multi-unit abutment connection. We mill a lot of PMMA and we mill a lot of titanium. Those are both one-to-one materials. So um, thanks to Yago. He showed me a video, Yago from Sim System. He showed me a video a couple years ago. It was of a tool manufacturing a multi-unit in one go. And he said, man, look at this. I've seen this. I want to start working on this. So together, Yago and I have gone through this venture. We've developed a tool. We've manufactured the tool. We've tested the tool. It is currently in operation at Elite Dental Manufacturing. I have milled over 100 multi-unit abutment connections with this tool. And what it does is it takes that operation from 15 minutes down to 5. On most of our cases, we have 6 implant sites, 6 multi-unit abutments. So saving 10 minutes per site is 1 full hour in milling that we're saving. And those numbers were for a titanium bar, but similarly for PMMA. So it basically just goes in. I got an awesome video here that I'll show you. It is a very quick operation, right? This video is not that long. We may have
It's
to
like a
watch
hole
it on
punch.
loop, but it just literally goes in and hole punches, right? And Yago and I spent 2 full days, like we were talking about, listening to the machine, like we have a stethoscope, running different speeds and feeds on this tool until we got it optimized. And then we've been running, tool, like how long can we run it? How many implant sites? and that's about the point of testing we are now. I've done over 100 on one tool. I have 50 of these tools waiting to go. So we're just right in this sort of development stage, but it's actively in use and it's freaking awesome.
Love it. Absolutely love it. Great work, Austin. Cool to see that kind of innovation, and it's ultra simple, solves a unique problem. I'm sure there's a lot of people out there like, I could have thought of that, or maybe some people did think of that, but you've executed, validated, and are using this wonderfully simple MUA tool.
Yeah. I was when I saw it, I wasn't waiting around. So like I designed the tool. I sent the tool to the tooling manufacturer, right? And then we had I don't know everything about tools, but me and an engineer at Sierra Dental Tool worked together, got a couple kinks and got a couple specifics, and we had this, we'll call it a prototype tool, right? But it's working like a champ. So I think that goes to just say that
Hmm.
we all thought about it as hard as possible, and I wanted it done as fast as possible. So I've gotten it made, and I hope to get it in your hands.
Can't wait. Can't wait, Austin.
Uh-huh.
Let's transition to the replace geometry. I think this is an important topic in how, when you design a geometry in 3Shape or exocad and that you create your STL, there's this point cloud mesh being created that, yes, that mesh is accurate. However, it is not the same as a replaced geometry. So, talk us through how they're different and why you use replaced geometries in all of your CAM processes. Even though the shape is in the design, you're going to replace it with the replaced geometry. So, just talk us through that.
Yeah. So the STL should have the shape of the screw. It should have the MUA. It should have all of that. And it's pretty good. It's a pretty good design. But the thought behind the replace geometry is we want to ensure pristine manufacturing, and we want to be able to repeat that manufacturing over and over and over again every time we mill that screw. So for us, the list is long, but for a particular office, it may be just means identifying the one screw that you use, getting the replaced geometry for it, and then fine tuning things. I think the most simple setting is like the width of the screw channel. So when you manufacture something, when you center something, you want to make sure that that screw passes through. So you may alter the diameter of that screw channel, the width of it. And you don't want to have to do that every time. Every time you get a full arch case or every time you nest an arch, I've got to modify this particular parameter. So replace geometries allow us to save those settings, and they allow us to insert them when needed. And what I mean is like when you're milling a full arch case with a multi-unit abutment, we replace the geometry every time. We never just mill the STL.
And this is important because you could mill the STL and you could get acceptable results, but you have eliminated that behavior from your workflow. And I don't want to put words in your mouth, but I can only guess it's because when you use the replace geometry, you're eliminating a potential variable that you no longer have to worry about.
Yeah, that's exactly right. It's peace of mind. It's being able to repeat it. So, I mean, it's terrible when you've got a full arch case sitting on your bench and you go to screw it down onto the model and you get the five of them in and you're on number six and it's like, or it squeaks or it just doesn't go all the way in or it doesn't engage with the multi-unit. And you got to identify, what causes that. And a big part of that is using replaced geometries. Yes, I've got four DES 19069 screws here. I need them all to mill the exact same way, whether they have angle or not. Angled screw channel does not affect the replaced geometry, right? The geometry is about this connection. Angling the screw channel will then call for the T tool. But when we're talking about just the geometry alone and replacing that geometry, um, it's just about the connection and the screw seat.
So maybe show us how to use the replace geometry and what you're doing. So you've got the STL. It's already got the
Yep.
geometry in there, but you're
So
putting this.
we got
Go
a
ahead.
cool view here, right? It's called like the wireframe view inside a sim system or inside a mailbox. So what you see is the mesh geometry of the shape of this arch, but then embedded you see the replace geometry, the shape for it to manufacture. If you go in here and you click on certain aspects of it, you can see things like the width of a screw channel, right? How wide this is. It's exactly 2.6 millimeters because that, for me, it lets the screw slide down just enough and it gives us some wiggle room if, for instance, you got a dull tool or you're milling this with a flat-ended tool, and let's say that tool starts to get a taper to that 90-degree
Mm.
edge. So you build a little tolerance in, right? Not enough to where it's excessive. You could see a gap around the screw, but enough so that you can consistently manufacture it. So we've got the screw channel, right? Then we've got the thread hole. Thread hole is, you may not think this, but the thread hole is one of the most important things about the screw hole or the replace geometry. Let me see if I can get down in here.
That's the channel for the screw threads below the head of the screw, now engaging with the MUA.
Yeah, I'm going to select a different one. Again, you do this setting in, uh, and I'll show you that, but in the back end of Mailbox. But let me see if I can select this thread hole here. Yeah. All right. So right here. So I've selected the thread hole. Again, you make these settings in a menu I'll show you. Don't let me forget to show you this menu. But the thread hole diameter, if you angle a screw channel, right, the thread hole has to be wider than the T-tool. So if your replace geometry has a thread hole in it that is 1.3 millimeters wide, and you try to angle that screw channel, none of your T tools are going to fit through there if you have
Mm.
mine. Like we have a 1.4 and a 1.6. Well, if the thread hole is 1.3999, it's not even going to try to pass through. So you've got to anticipate that in your geometries. I mean, we've done all the thinking about these replaced geometries. So again, if you use most of the standard screws, like I've got all of these available, we can send them over to you. They're all fine tuned. Now, your machine and how you manufacture in your tools, but I could certainly provide these to you guys if you guys are interested in getting replace libraries or the ExoCAD library to help, assist in that. So we've looked at it. Let me show you how you do it. And then I'll show you the settings behind them. So let's go back here to our standard view. In Mailbox, you can see here this arch got 6 implant sites. You will go to Tools, then you will go to Connection, and you will click Replace. Okay, so you're going to identify one of the implant sites. You're going to tell it actually which it came from. So maybe what's in the STL. I know this is a DES 19018 screw. And then you're going to tell it what you want to replace it with. So I know that looks a bit redundant, right? We had the 018. We're putting an 018 in it. Why do we do that? Again, repeatability. So we just want to make sure that every time we mill this screw, it is milled the exact same way every time. So what it will do is it'll extract from the STL. It'll select all of that geometry. It will delete it, and then it will replace it with a replaced geometry that is perfect.
Yeah, it's this idea that if you took the geometry from the three shaper exocad export, the point cloud export, and you were to take 100 of those geometries and overlay them, there would be slight variation from geometry to geometry. If you took 100 replace sites and overlaid the geometry, they're all going to be one-to-one clones.
Yeah. Yep. That's exactly right. That is exactly right. So now let me show you a little bit about the settings. Here's where we can get in the weeds. Here's where I want you guys to reach out to me directly and we can go into more detail. But I will go into what's called configuration. So in Mailbox, you get all these great settings for speeds, feeds, tools, replace geometries. Like in the expert, I think it's the standard, but the expert mode gives you kind of unlimited access. So I'll show you here. We have the uh, replace geometries. Let's go to here. And I'll identify that screw we were just looking at. So we were in the
And
580.
do these geometries come included with Mailbox? Do you got to reach out to Mailbox and get them added?
Most will come with their standard. There is a standard library that is provided. Any specifics that you may need, it may not be in there. Most likely, we've created them and they are available just directly through your reseller, and they can implement them there.
Awesome.
So this is the settings side behind a replace geometry. And what you'll notice is it segments out different portions. So this particular portion, we talked about it earlier, 2.6 millimeters. That's the width of that screw channel. Okay. Then we come down here for our thread hole diameter. I guarantee you that when I created this one, it was set to 1.6. And because it was equal to the tool used, it didn't allow that tool to go in. So we've built some tolerance in, right? So we've changed this to 0.674. So now Millbox is smart enough to know I can pass through.
And regardless of what was used in exocad or 3Shape, this replaced geometry is now locking in this geometry so that you can mill it with the T-tool.
Yeah, and that actually drives home the topic from earlier. If you were to have tried to mill this with an angled screw channel using the STL, and that STL's thread hole was less than 0.6 1.61, then it wouldn't have allowed it to. You would have had a simulation that wasn't correct. It didn't look proper.
And we got a question from Amir that the replacement geometries, are they exactly like the source, or is there any deviation to worry about in the position related to what it's replacing?
Basically, it's exactly the same. We can get into the weeds about them all having slight nuances from, this bottom portion here, actually this curved portion here of a desk versus a Rosen versus a Powerball. They're all a little bit different in their mesh geometry, but it's not enough to worry about. It's not that type of concern.
So it's a net improvement using the
Yeah,
replaced geometries. Have you found any issues using the replaced geometries where you're like, that caused a problem?
no, just the reverse of that. I have had problems just milling the STL.
Yeah, yeah, that's a great point. Austin, anything else you want to close with? And guys, if you got any questions for Austin and his cam tooling wizardry, please ask them now, and then we'll transition to what you do after you mill PMMA and how to apply EasyGum. But Austin,
Yeah, well,
any
yeah, I
points you
got
want
some.
to make as we wrap up?
Well, just if I can be of an assistance to you guys at any capacity, whether you guys are already milling or want to mill, have trouble milling, or are successful and want to do more of it, I'm here for you. Elite Dental Manufacturing can manufacture this stuff for you. If any of you guys will be in Chicago, I get there on Wednesday, be there all week. So, yeah, I'd love to connect. I'd love to shake your hand. I should have something on that says Elite Dental Manufacturing. It probably looks exactly like this. It just has my logo on it. Um, Come up and say hey to me. I mean, it's one of the best weekends of my life, so or of the year. So let's connect if you're there.
Awesome. We got a question from Leonard that is making a distinction that the replace strategy removes the abutment surface entirely from the STL. And if you select a 19.069 on a vortex connection, the arch is modified and your STL file from exocad and 3Shape are different from the file now in Mailbox.
Yes, that is true. So if you go from one screw to another, inside of Millbox alone, it's going to delete that portion of the geometry and insert a new one. As far as it physically changing the STL, like you having now that you've used the replaced geometry, producing an STL without going into some 3D. Um, it doesn't do that, but it will make alterations to this STL to make it achievable and make your screw fit. That is true, yes.
Awesome.
And
Awesome.
does
Awesome.
that answer
Awesome.
your question? Feel free to like elaborate a little bit. I'd love to just make sure I answer your question.
Leonard said yes, thank you. I was just repeating the question. I think Leonard's IQ is a little bit higher than mine, so I'm just passing it over to you. Um, but I mean, I think the conclusion here is that all things considered, you always use replaced geometries. They've always made things better for you. You haven't had other issues that have caused problems with using the replaced geometries, and you would highly recommend it at this point. And my gut is you just won't work without them anymore.
Yeah, because what I want to do is when I have an issue, like let's say your MUA is not fitting the analog, or the screw is not going all the way down, or it's not engaging. I want to be able to identify what exactly caused that. Was it my burr was dull, or do I need to make a modification here to the geometry? One thing we didn't talk about is like milling just single unit things. You can mill a bunch of single units. You can try the screws and fits, and then you can dial those things in here in this menu and save them. And then you can sort of just look at the results as you go.
Love it. Love it. Love it. If you guys have any more questions for Austin, you can drop them in, but we're going to transition to EasyGum. So Austin's going to mill a beautifully accurate and detailed PMMA provisional in this case. And then now, how do you apply pink aesthetics quickly? Shauna, take it away. I'm going to spotlight your video for everyone. And so here we are.
All right, my turn. All right. I'm kind of going to just run through this a little bit quick as far as the prep work goes. You can design a little bit of a cutback if you want to. I am really big on having something to finish too, as far as at the finishing line. If you want to do it by hand, you can do it by hand too. These are the three burrs that I really like to use the most. These are from Comet. They're the yellow stripe. It's like a double crosshatch kind of acrylic burr. Or you can use a larger round burr. And what I'm doing is I'm just really defining where I'm going to be finishing this at. Again, you can design it into your prosthetic, or you can actually do it by hand. I do a lot of mine by hand because I know exactly how much that I want to do. Once you do that part, go ahead and sandblast the tissue area, steam clean, and then air dry super good. So I've already done that part, and we're going to go straight into bonding. One thing with the bond, it does come with the Harvest All-in-One Bond, these little micro brushes. I do like micro brushes, but it's not my favorite to use on these all the way across. I do like to get these disposable paint brushes. They're 000 on Amazon. And I'll kind of show you the reason why I like it is when I use the micro brushes, I really don't feel like I can pull it um, out thin because this kind of acts like a sponge and it's continuously picking it up and putting it down. Whereas with the paintbrush, I feel like I can get a little of a thinner coat and more even. So I'm going to start by painting at one end and then working my way. Something on that one. Try this one. It's setting up on me. Oh no. So a little bit goes a long way. And then another reason why I do like the brushes is I can actually get down and around the papilla. This is like a super important part too. If you're not getting the bond down in these areas, this is probably the most vulnerable place that you're going to have some lifting
And this is
when you go into curing.
an etchant, primer, and bonding agent all in one.
Yes,
And you have an Amazon cart, isn't that right? With like these brushes, I think you have a link to these
I
brushes.
do. I do.
Yeah, they're disposable. They're super cheap on Amazon.
I think I get like a pack of them for $6. Stretch that one. Good. Once you get to the other side, you're going to air dry lightly, but make sure that you're air drying away from your connections. You don't want to blow the air up and over, especially with PMMA. So you're blowing downward. I'm going to actually use my auto flash. I'm going to place this in. It's going to be 1,000 flashes. Now, when this comes out, I always like to check to make sure that the bond is actually cured all the way. And by doing that, I'll be touching it and making sure that there's no sticky or tackiness. It shouldn't feel wet. It should just look like it's kind of shiny.
To everyone out there, I'm just dropping in a link to the EasyGum instructions for use that go over all the details related to sandblasting and curing, and whether you're using an LED cure box or a handheld. All those details are there in that support article.
And once this does come out and I check it, I'm going to be placing modifiers. Now we have 5 intense modifiers, and these are going to be like the colors, like the reds, the blues, the purples. These three are my absolute favorite. These are going to be the dark violet, the red plum, and the bright red. And I think just about every case I've ever done, I've used these. Almost there.
And you've done a lot of teaching using the
Mhm.
handheld. You also
I
have
do.
the auto flash. It's probably a little
And that's
faster if you're doing higher volume workflows to use an auto flash.
it is. I like it. And also there's no nitrogen either. It's you don't have to use that.
Nice.
So now checking it and then touching it with my finger, there's no stickiness or tackiness. I mean, it just looks like it was glazed. It's kind of wet looking. So you definitely want to check it and make sure if you're not getting a full cure, there's a couple of reasons why. It's either your prep work wasn't enough, you're not opening that surface, especially on PMMA, it kind of has that um, super shiny kind of surface like you can see on the teeth. You need to open that up so the bond can kind of seep in a little bit. If
So,
not, then you need to check and make sure that you're doing enough flashes.
so it's going to be shiny, glossy, but dry
Yep,
and not sticky or tacky.
not sticky or tacky. So first, I'm going to use the intense modifiers. The red plum is always my first, and I'm going to be just placing dots right along the finishing line.
And since this is all going on under the strip, you work a
Mhm.
little more quickly and you don't have to be as precise because this is just sort of adding that red contrast.
Yep, this is kind of like just the contouring. This is going to shine through the strip. This is kind of why it makes it such a quick process, is that we can get kind of an elevated look without having to go back and really kind of paint this in on top. So I'm just connecting the dots and then pulling it down to the papilla. Connecting the dots, pull it down to the papilla. And it's not pretty yet, but it will be. I'm going to go in with the bright red. And I'll do the same thing. You do not have to cure in between of using these. You kind of just want the colors to kind of float together.
Yeah, so you have three different modifiers and you're going
Hmm.
to apply all of them, layer them one over the top of each other, and then you'll cure all
Yeah.
three together.
Yep, all three together. Now, these probably, if I had to use two shades, it would be these. The dark violet is just a little extra, and I really strictly just leave that right at the top, the finishing line, and let
Well,
that kind of float.
we know you like to be extra.
You do. I'm a little extra. There we go. And I want to make sure that everyone knows too, it's like this isn't like a stain where a lot of the stains you're having to kind of paint on. You're floating this on the surface. So I'm not, when I'm kind of pushing and pulling it around, I'm not pressing all the way through the material. I'm kind of using the tip of my brush and then kind of pulling it into the areas that I want. If I were to kind of press and like really paint it, it's going to thin out and you're not going to get the intensity of these colors. So I'm going to put it back
And
into my, oh,
we
go ahead.
while you do that, we sent some demo kits out to people that registered. I'm curious if anyone here is following along with Shauna. Give us a thumbs up if you're like doing the demo with her. Obviously, we can't see you or hear you, but if you're following along, we'd love to hear, love to know. We did send out a number of the demo kits with the dark red plum to the
Awesome.
audience.
So taking your strip out of the box, it's going to be sandwiched in between these two little plastic pieces. Now it's going to be cool. I like to kind of warm it with my fingers. So it's kind of the consistency of like a stick of gum. So you want it to be able to be a little bit bendy. Don't overheat it because it's going to become too sticky. But I just enough to where that coolness goes away and then the heat my fingers warms it up and it's a little bit more pliable. And once this is done and it comes out of the box, I'm going to be pulling off one side of the strip and leaving the other side on. Almost there. And then my first tool that I'll be using is going to be that Harvest Papilla tool. It's got this little loop on it.
And Shauna, talk to us about there's no
Mhm.
reaction layer. You don't need any cover
No,
gels with EasyGum.
nope, no cover gels whatsoever. So once it's done curing, when we cure this strip, it's going to be solid and it's totally ready to be polished. And I'll show you that part too. All right. So I'm going to pull off one side. And I like to line it up at the finishing edge. I'm going to press it right at the midline. And I'm going to hold it firm with my thumb. And then as I kind of pull it back, I'm going to push it into the finishing edge and give it a little press. I'd rather more of it kind of go down towards the teeth and up and over towards the connections. And then once it's in place, you can go ahead and take that strip off. And then papilla tool, you're going to go at the height of the gingiva. And all you're going to do is press and scrape straight down. And you can save it. I just, put it into the palm of my hand. So scrape it. And this part
And
is not going to be pretty yet.
what's your working time with EasyGum, Shauna? How much time do you get to work on the
Um,
case?
well, usually this only takes me 10, 15 minutes to do. If I had to go longer, I guess I could. When I'm doing it on zirconia, I get a good 40 plus minutes working with it. But I do have a Harvest light bar, which has a warm setting that is used for resins.
Yes, we have um, a dental light. If you guys haven't seen that, come check it out in Chicago. It has three different light temperature settings. One of them is a warm setting, so it's got low UV and it extends the working time of EasyGum and any composite that you're using. The opposite would be if you're sitting in front of a window, like with the sun shining in, that wouldn't be good, and that would for sure shorten the working time of your composite. But if you're under the harvest light bar in the warm setting, I've heard, 40, 50 minutes is achievable.
I
So
can
the next tool that, oh, go ahead.
I can attest to that. I have a bunch of fluorescent overhead lighting here, and
Yeah.
Rob sent me a demo kit, and I tried to learn it. It takes some practice, but it's an easy thing to learn. You just gotta force yourself into doing it. And I think that's the benefit of these demo kits is you can easily just give it a shot on something that's not going in the mouth. But the extra light that's on uh, can lower the time. So I think I went from about 10 minutes of working time to implementing the harvest light and certainly seeing 30 to 45 minutes. It was night and day different.
Awesome. Thanks
Yeah,
for validating me,
I know,
Austin.
right? Yes. So what I was doing here is I was using a silicone tip. I was dipping it in a little bit of the bond so I can slide across. So starting at the finishing edge and using the thicker part of the tip, I'm going to be kind of painting downwards. What this is doing, it's going to lower the profile of the resin and it's actually pushing it down and into the papilla area, where that's kind of like the neglected part generally when people start using this. So this is like a little trick. It's not pretty, just pull it down towards the teeth because the next instrument that I have will help with that. And then kind of do a pass with your finger just to tap it into place. And this last instrument is going to be an Explorer. I love it. So this is where I'm going to shape the papilla and remove what was pushed down onto the teeth. So I like this pointy end. So we can shorten those. And then I can use the back end, the curl part of the Explorer, just to kind of ride up the tooth and then just kind of
Hmm.
shape that
Love that.
gingival margin. Just like that.
And don't be shy about questions. If you guys have any questions on EasyGum,
I love
love to
questions.
support you guys. And if you guys get into any advanced workflows with EasyGum and you want some help, you can go to harvestdental.com and we have a one-on-one that's available with Shauna, or she'll do a virtual training if you need. It is worth mentioning that EasyGum is only available in the United States for now. We're looking to expand, but for our international audience, unfortunately, EasyGum is not available for export out of the US yet. But that is a question we get a lot.
There we go. And I'll just do one more pass with my silicone. Really make sure I do a final pass, make sure that this papilla tip is nice and tucked in. The papilla tips are supposed to go between the teeth, and you don't want that setting on top. So I always make sure. And if it gets a little bit too sticky, just do a light dip in the bond and then can continue rolling over it. There we go. Let's see. Oh,
So is that ready
and
to
I
cure?
dropped. It's ready to cure, but I have one little trick. Oh, and I dropped it on the floor. So to do a little bit of, you can level this out, and it's a quick little trick to give you a little bit of texture, if that's what you like. It's a little sponge. I've just kind of took it off of a piece of the Scrub Mommy. It's like the little sponge with the smiley face on it. I liked these. So you're just gonna roll over it, gently pressing, and it kind of gives you that supernatural looking texture. And then now it's ready to cure. We're done. Now, as soon as this comes out, which I'll show you what I use to polish, because I do prefer polishing over glazes.
Yeah,
Let's
you
put
can
that
light
in.
cure glaze,
Mhm.
EasyGum, of course, but maybe just
Yeah.
while that's curing, talk about your experience with light cured glaze, why you prefer polish.
Yes. So I do like polishing over glazes. I feel like glazes do break down in the mouth. I was experiencing, because I've been in an in-house situation where I've able to see patients and they were complaining of terrible taste in the mouth. And some of these provisionals that were going a little bit more long term, the glazes were breaking down. I was noticing they were getting super sticky. And it was like everything would stick to them, no matter how much the patients were brushing. or paying attention to everything. It's just, you couldn't stop it. And they were just really gross. So I really kind of wanted to change things up and try polishing, which I came up with this. So I only use three tools with the Harvest Speed Polish. And I'm going to use a stiff bristle brush. This is just a felt wheel. And then I'm going to finish off with just this cotton buff. And we're going to get super shiny. As soon as that pops out, I'm going to show you. And then we're going to start first with the bristle brush with the speed polish. Now, the speed polish, I don't know if you've ever used it in the past. It used to be kind of a little bit more liquidy. It's more solid now. I love it. I use this on metal, PMMA, zirconia, anything printed. I'm pretty much just little Swiss Army knife of a polish. All right. So before we were saying you do not have to put any kind of gels. We can go straight into polishing,
Shauna, maybe talk
which
for
is my
real quick
favorite.
on confirming that EasyGum is fully cured. You can tap it, scrape it
Yes.
with the Explorer, and it should have a very hard sound to it.
Right. So when you're checking it, you should be able to put an instrument through it, scratch it. It's not going to come up. It's not going to, when you go to scratch it, you're not going to get any of the kind of lines in it. You're going to have like a high pitchy noise to it. But definitely check your EasyGum, make sure that you're curing all the way. If you're using a handheld light, I will say this. If you're using a handheld light, which I love using, mine will cover about two teeth per section, but make sure that you stay in that section for the full term of the 20 seconds before you move to the next one. So I know a lot of people were just trying to like kind of guide over and do one of these. That's not going to cure it because this section needs that full 20 seconds and then you can go all the way around.
Just got a question from
So,
John on the cure setting for auto flash. It's 1,000
yes,
flashes.
1,000 flashes. So with the bristle brush, I am putting a little bit of weight into my hand, but I always start with the EasyGum first and then I'll work my way down to the teeth a little bit lighter. So here you'll start seeing a lot of the colors that we put underneath the script kind of start to pop through.
And Austin, when you mill these yourself, do you offer a service where you'll apply EasyGum?
We sure do. Yep. Yep. Milling dentures and temporary PMMA with EasyGum.
Love it, man.
Sometimes with they honestly are like made for these full arches. I don't know if you notice like how
Yeah.
well, it's done to first molar, but one strip per arch is pretty awesome. But the way that, like she would save a little bit on dentures, you may have like a taller flange here and there. And it's so nice just to take what you've saved or the second strip in the package and just fill those areas in and how easy they blend together.
Yeah. So what I'm using now is this is just the felt wheel. I love this because I'm really big on I like that smooth transition to the intaglio. So I'll actually put a little bit of weight behind my hand and really kind of guide it back and forth and down this finishing edge.
Yeah, I think that's a very critical point. I don't know how much exactly training is done on these things, but right there is like the food trap nightmare, right? So
Yep.
when you transition from that gum tissue into the intaglio or the underneath side of that prosthetic, having that transition be smooth, like you said, is very important.
It is. It's huge. And that's really why I like to make that finishing edge. Like then you can design it or cut it in yourself. I'm using the cotton fluffy, and I'm not using whatever's on here. I'm just going to start buffing out. And this provisional is the Harvest the DCL, so it shines super easy.
And what we see there in between the teeth, that is the speed polish. So you're actually able to
Yeah.
see it kind of work its way off and polish around.
Yep. Keep rolling back and forth.
John, we got a question on do you put anything in the MUA connections to protect
But
them from getting any stuff in there?
yes, I actually do. So if I'm doing a live case, so I don't actually have any connections in this one. I'm just kind of using it as a sample, but I've made my own. So I've cut some analog down, um, and I have a set for whatever kind
Yeah.
of connection that
And,
I'm using.
and Austin milled his own.
Yeah,
Yeah, I mill them by the thousand. So if you guys need MUA protectors,
yeah,
but yeah, we definitely started by angle grinding analog after analog after analog.
Austin, do you like just sell those like by the
Yeah,
dozen or
yeah, yeah. They're $8 a piece.
nice?
I'm gonna have to get some. I've been
I'll
making
be in
them
Chicago. I
myself.
promise you. I promise you, if you see me in Chicago and you say, "Hey,
Yeah.
Austin, I saw
Ugh,
your webinar with Harvest and I'd like a couple MUA protectors." I mean, if you
yeah,
normally do 4 unit cases, I'll give you four. If you normally do six, I'll give you six. But yeah, that I made them to make our lives easier, so be
yeah.
happy to share them.
It's very generous of you, Austin. You may
There
run
we
out
go.
on day one, but your
You know,
pockets
Right?
will be heavy.
no worries, no worries.
From
Yep, that's
here,
what.
I would run over and just steam clean, air dry, but I'm just using my towel, so there is a little bit in between, but you can see where this is really shining up. It's a much more natural finish, and it does stay this way in the mouth. So less staining. It comes out a whole lot healthier looking, and less kind of stinky for the patient, complaining of, not tasting good. So that's one of the reasons why I kind of transitioned over to polishing. But yeah, that's where we go.
Yeah, and of course, 3D printing is an option. But
Yeah.
I think many people respect milled PMMA as a great choice for an aesthetic provisional or a long-term provisional, something that you can have confidence is gonna, last a while.
Oh, absolutely. Now I will, if these test drives, if they're going to go a little longer than just a few months, I definitely will choose PMMA over printed.
Yeah, and the PMMA polish is nicer.
Yeah.
The multi-layer aesthetics look nice. Printing is obviously it's monolithic just by nature of printing or monochromatic, but
Yeah.
super awesome. Shauna, we had a question from John. Do you need to
Mhm.
use nitrogen on the final cure in the auto flash?
No, you do not. You do not need to use nitrogen at all on any of the cures.
And that's because
And
there's no oxygen inhibition layer that's being formed, right?
right, so this resin's a lot more like clinical resin that we see like putting like with fillings. Once it's cured, it's pretty solid. Unlike some of the lab resins that we've used, like in syringes, where we've had to cover them, or put them in glycerin when curing.
Hmm.
Yeah.
Awesome, guys. We'll wrap it up. We got a few more questions that came in for Austin. So, Shauna, you can transition back to,
I'm coming back.
let's see. And then, all right. So, Austin, we had a question on um, in what software do you edit the interface geometries if you wanted to, like you had talked about making that interface geometry like a 0.47, right? So, where are you editing that interface geometry?
Inside of Mailbox, there's the configuration menu, and that's where all of those settings can be found. Actually, you can create your own replace geometries there too. So when you go to tools and you go to connection, then you will see identify, replace. There's a few different options there, but you can actually, even if you don't have the replace geometry, you can identify and create your own from the STL. We did mention like we don't want to follow the STL because there can be nuances. So if you are doing that, you want to make sure that the geometry you're pulling from a raw STL is the best it can be. So you can create your own, you can edit any, whether you created it or you get them from somewhere else, you can edit them all within Mailbox.
Awesome. Awesome. And then another question from John. Do I keep the red on the All-in-X, the MUA and the screw hole where it was red in the cam software?
Yeah, so the use of those red caps is what they're known as, red caps. There is a red cap on the occlusal surface where the screw channel is, but then there's also a red cap over the MUA. The reason that is it tells Mailbox that within these two red circles, this is an important connection. So do not run any roughing passes inside of that screw hole. To elaborate a little bit, when your part is roughing, right, you don't see the screw channels. If you took the red caps off, when it got done roughing, you would see where it had gone down in those screw channels. So it also helps optimize the tool paths. The roughing passes basically get blocked by it, and then the tool paths for finishing don't get blocked by it, and they can go within there and perform their jobs.
Dennis asks the differences you see between Millbox and Hyperdent. I know you use both. Um, any comments you want to make on those two cam softwares? There's probably two camps, like you got your 3Shape and ExoCAD camp, but just maybe share a little bit on Millbox and Hyperdent and how you use them.
Yeah, I run both of them. I run both of them every day. We I'd like to say they're both capable of doing the same thing. It's really comes down to who's supporting your particular cam. Hyperdent and Mailbox are certainly the two most predominant. Um, and just having a good reseller. Doesn't matter if you got Hyperdent or you got Mailbox. It is very similar to the 3Shape ExoCAD thing. And then unfortunately, the salespeople use that. I don't mean to speak bad about anybody here, but I mean that sometimes they say, well, actually, you need to switch to Mailbox to do this. Or actually, you need to switch to Hyperdent because it does this better. And it is my opinion. And from what I see, they're both capable of producing these like pristine, perfect arches that are repeatable. You just need to know how to use the software.
Awesome. 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 Well put for a loaded question.
Yeah, and like it, like you said, it's two camps, but they should all get together, right? We all got milling machines. We're all talking cam. Why don't we just benefit each other? And I think we do that by sharing challenges and how we overcame them. So thank you for having me.
Mhm.
Awesome. Well, guys, the audience stuck with us for an hour and 22 minutes. So thank you, everyone. I hope this was exciting and insightful. We will post this recording to our YouTube channel. You can reach out to Austin. I put his email in there, Austin at EDM Dental. I'll put Shauna's email in there, Shauna at Harvest. I can't talk and type at the same time, harvestdental.com. Um, and you guys can reach out to her.
I don't know if that is
There
Ooh,
you
that
go.
backwards.
it's the best cards ever. It's fuzzy.
Yeah,
Get it back
whatever. If you see me, come grab me. I'll
up.
give you these. They're leather and gold. So
I
And
actually still have it on my bench.
I'll end with
yes.
this. If you go to the Harvest website and click book a one-on-one demo, You can book a demo related to EasyGum. You could book a demo related to the Harvest Nano Zirconia. You would just click on the one you want. If you wanted to talk about the fundamentals of EasyGum, find the day and time that works for you, and Shauna will be there to support you guys. We want to support you, make sure you're successful, and whether you're just getting started or you're doing more advanced cases, we want to support you guys. So come see us in Chicago. Harvest will have a booth there. Austin, I know you'll be there walking around. Maybe Austin will be hanging out with us for a little bit, but thanks everyone for being here. We'll wind it up and say goodbye and just thank everyone for joining us.
Yep. Thank you guys. Thanks for having me, Rob. Good to see you, Shauna.
You
We'll be
too.
in touch. See you guys.